In this question, they say a cubic polynomial, which is divisible by x minus 1, which means that a cubic polynomial, that means the highest power of x is power 3. And then at the same time, they say that when fx is divided by x squared minus 1, then the remainder will be kx plus 8. Now it's come to a question is, everyone know that we try to express the original function, try to build up the original function, but how can we build up the function? If we just look at here, we may consider that fx is equal to x minus 1, and then the remainder should be a quadratic. We may write in this way, but at the same time, don't forget it. This one, they say fx is divided by x squared minus 1. If there is something x power 3 divided by x squared plus 1, then what is the quotient? It should be something x power of 1. That means a linear expression. So not only you can let in this way, you may also construct fx in this way. Fx is equal to the quotient times x squared minus 1 and then plus the remainder, the divisible part and the not divisible part, and that is our quotient, and we know that the quotient should be linear, x power of 1, so we can let it be ax plus b. Now come to a problem is which format will help us to make good use of the information. This is not good compared with this one. The reason is we need to let 3 different unknowns here, so it's difficult to log the value of a, b, and c in this case. We try to use this one. We let fx is equal to the quotient ax plus b times x squared minus 1, and then plus the remainder here they say is kx plus 8. And given that we know f1 is equal to 0, is because they say when fx divided by that, so we can get the remainder by replacing x by a suitable value, which is 1, because 1 minus 1 gives you 0. And divisible, this means the remainder in this case is equal to 0. That's why the remainder is equal to 0. Now we try to combine these two information together. f1, that means we consider x equal to 1. When x equal to 1, we have a times 1 plus b, and then 1 squared minus 1 plus k times 1 plus 8. Even though it's not complicated, but f1 is given that is 0. This is a plus b. The key point is this factor is 0. So even though we have unknown here, but this whole part is just simply equal to 0. So we have k plus 8 equal to 0. K is negative 8. In part B, before we start, of course, we should update the information. It's equal to ax plus b times x squared minus 1, and then plus kx plus k, that means minus 8x plus 8. We update the information and see what is the additional information. They say that x plus 3 is a factor of fx, so similar reason, f negative 3 is equal to 0. They try to tell you that when fx is divided by that, the remainder is 0. So given that f negative 3 is equal to 0, therefore we consider when x equal to negative 3, f negative 3 is equal to negative 3a plus b, negative 3 bracket square minus 1 minus a times negative 3 plus 8. And then simplify that carefully. And then both sides divided by 8. We have negative 3a plus b is equal to negative 4. Of course, you have two unknown here, then they give you another information. When fx is divided by x, then the remainder is 24. So with two equations, then you can solve a and b. And also given f0, because when the divisor equal to 0, then x equal to 0. The remainder is 24, so they say that f0 is 24. So we consider when x is equal to 0, f0 is equal to a times 0 plus b. 0 squared minus 1 minus a times 0 plus 8. Simplify it. This is replaced by 24. A times 0 disappear, so only b is left. B is equal to negative 16. Therefore, since negative 4 is equal to negative 3a plus b, 3a is equal to b, that means negative 16 plus 4. A is equal to negative 4. So we have the full picture of fx. Updated information, fx is equal to a is negative 4, xb is negative 16, times x squared minus 1 minus 8x plus 8. Later on, they ask us to solve the equations fx equal to 0. But before that, let us tidy up what is this first. So, negative 4x power 3, positive 4x, and then we have negative 16x squared, positive 16, minus 8x plus 8. So, group similar terms, we have this expression. This is the original function. Now we are going to solve this equation equal to 0. So consider solve fx equal to 0. That means negative 4x power 3 minus 16x power 2 minus 4x plus 24 equal to 0. We find that all the terms are divisible by 4. And usually I don't get used to the first term coefficient is negative. So I divide both sides by negative 4. X power 3, positive 4x squared, positive 1x, and then negative 6 equal to 0. Based on the information here, they give you one factor, which is x plus 3. They also give you another factor, is x minus 1. So if you perform long division, maybe you can divide by this or this. Both of them will lead you to the answer. I consider that I divide it by x minus 1 maybe. When we perform long division, we use the first one divided by the first one here. So x power 3 divided by x, we have x power of 2. After that, the second step is to multiply the divisible part. That means x squared times the divisor here. That means x power of 2 times x minus 1. And then if we expand it, it's give x power 3 minus x squared. Final step of one cycle is we use this one, subtract this one to calculate the remainder of this part. So 4 minus negative 1, we get 5x squared. Then repeat the same step. 5x squared divided by x, we have 5x. Therefore, what here should be 5x times the divisor. We have 5x squared, negative 1 times 5x, negative 5x. After that, we x minus negative 5, we get 6x minus 6. So this is 6. And then we find out there is no remainder, consistent with our assumption. So it is x minus 1 times the quotient, x squared plus 5x plus 6 equal to 0. You may say this is 0 or this is 0 and then you use calculator, or you may further factorize this quadratic expression. They give you one hint already. X plus 3 is also a factor. So this is x plus 3. Then by the cross method, this is x plus 2. By the zero product rules, something times something times something equal to 0. That means at least one of this factor is equal to 0. So we have the first root equal to 1, the second root equal to negative 3, the last root equal to negative 2. All of them are integers. So all roots are integer. Which means that we agree the claim. The claim is correct.